Hello, and thank you for joining my workshop today. Today we're going to be going over a lesson plan called Bringing Light to an Arctic Night. And I'm going to go over with you how students can incorporate creativity and design thinking into a STEM project with electricity and circuits. So just to start, I'm going to go over a little bit of an introduction to who I am, and then I'm going to get into why I love using cardboard for these types of projects. We'll talk a little bit about community-centered design, and then some maker materials and fun hacks, cardboard hacks. And then we'll get into making circuits and circuits with Santa Claus at the North Pole. And then we'll do some extensions to real world applications based on the learning that the students do in this lesson plan. So to start, I'll introduce myself. I'm the one on the left. My name is Marcy Klein. I'm actually a pediatrician. I was a pediatrician for over 20 years before I transitioned into STEM education, mostly inspired by the two kids on the right, which if you have guessed, you were correct. They are my kids. And my daughter, who is now a senior in college, designed a cardboard-based modeling system after she was inspired by a summer architecture program as a high school student. And she felt that architecture and building with cardboard construction really beautifully blends creativity, hands-on creative play with learning about the environment and STEM subjects. And she did not feel like there was anything in her early learning that was close to the experience that she had in her architecture project. And she wanted to create content and products for kids at an early age based on her great experience. Her little brother, Ethan, is now an engineering freshman at Northeastern University, and he is actually the engineer of the products that we sell, which is 3DuxDesign modeling sets, basically connectors and cardboard shapes. But the connectors can fit on all single ply cardboards, so students can cut up their Amazon boxes or shipping boxes that you have in class or at home and use them for a tool for STEM learning. I create lesson plans and content to augment the product and make it a little bit more academic and bring real world experiences into the lesson plans in the classroom. The reason why I transitioned from pediatrics into education was when my kids set up a booth at the local soccer tournament in our town and cut up pieces of cardboard and the 3D printed connectors that they had made. And what I saw was just magic. Kids were playing with kids that they didn't even know, kids with different languages were playing with each other, kids of different ages, parents were involved. It was just a great experience. And I felt that it was something worth pursuing with my kids. So why do I love cardboard as a modeling system for STEM and all of learning, really? So for starters, it's incredibly fun. There's not a kid that I have noticed that did not like playing with cardboard, all ages. We've even done professional development and corporate training sessions. Even adults love playing with cardboard. It's fun, it's creative, there's no rules, it's open-ended, and it's totally hands-on. A little bit more academically speaking, it helps with 3D spatial thinking, hands, fine motor for younger students, and then incorporated in lesson plans and curriculum. You can definitely include a lot of academics from geometry and engineering. We bring a ton of literacy into our projects through reading, research, and creative writing, but also all those 21st century skills, working together, communication, collaboration, critical problem solving. It's all stuff that you can do with cardboard construction projects. Why I love community-centered design and architecture. Architecture is this magical discipline where the math and this engineering and the sciences really blend with art and creativity. But more than that, it also brings in humanity, culture, diversity, um, nature, the environment, the climate, geography, all in one discipline. So it literally is like taking the world outside the classroom and using it for a platform for learning inside the classroom. And it also ties to real life experiences that our students are having every day. Here's just an example of a few different projects, and you can see the diversity and of culture, of the modeling, from different parts of the world. On this picture, we have children from Africa, from a New York City farmers market, from Thailand, a riverfront property, to a little village, a seaside village in Costa Rica. And you can just see how different these projects are based on the students' experiences, their culture, and where they live. All of the lesson plans, including this one, is going to be heavily rooted in the design thinking process. So students really need to understand the problem that they want to solve, and they really think through it carefully. They ideate a ton of different possible solutions. And then they go and they design a specific solution based on their research. They build and then they share, but sharing is not really quite the end. Once they share and they get feedback from peers or the educator or the community, they go back and they go and reimagine and they start the process over again. Part of the design thinking process is that learning and designing and creating is never ending. It's always a process and there's always room for improvement. And as soon as you think you're done, boom, things change on you, like you get a global pandemic and everything you thought was perfect. You have to restart and rethink everything. So it helps students be able to adapt to change and accept failure and imperfections and keep striving to improve their projects and anything that they're doing in life in any career. So going over some materials, if you got a maker kit, some of these materials you should have in the kit. If you didn't get a maker kit, don't worry about it. I have templates. If you didn't get those ahead of time, I'll be sharing them at the end. But here are some maker materials that work really well with cardboard construction and projects. In addition, you'll have other materials that you already have in the classroom or at home that you can use to augment projects as well. I'm not going to read everything, but obviously tape and scissors, glue, paint and crayons, craft paper, but also popsicle sticks, paper towel rolls are awesome. They're great for a lot of different STEM projects, any kind of upcycled materials that you might have. I love to have students bring a little toy of their own, a personal item. It just brings ownership into their project and it adds a little creative, critical problem solving when kids bring in a random toy and has to be incorporated into their project. In terms of taking cardboard construction from low tech to higher tech, we'll go over circuits today, but there's a ton of other materials out there that you can incorporate into your cardboard construction projects, like renewable energy using solar, wind, and hydropower. You can incorporate robotics. We use the Ozobot all the time in our projects, and helps students learn about driverless cars. We use the Ozobot because it works with our scale, but literally any robot can work. You can do MakerBit and make smart homes with motion detectors, climate control, tons of different opportunities with MakerBit, which I think I spelled wrong, but sorry. Then you can also leverage digital technology. So students, you'll see an example, they can do stop motion, they can do green screen presentations, using their cardboard construction as a backdrop, or not as the backdrop, but as the medium for using in their video. CAD, 3D printing, and laser cutting, all things that you can learn and use cardboard for, and then integrating digital 3D modeling, like rendering programs like Minecraft or CoSpaces and other programs that are out there, help students learn how to compare two-dimensional on a computer screen to three-dimensional hands-on. So it's a really great tool to augment learning with as well. Resources that I love, Scrappy Circuits has pretty much everything that you have at home that can be converted into a circuit. And they teach you how to do all different kinds of circuits. A lot of it I'm going to be doing with you today, but if you want more materials that you probably have on hand at home, that's a great resource. I love Carly and Adam's projects on Teachers Pay Teachers. They have a ton of seasonal type projects and holiday type projects, but a lot of their projects focus on, again, materials like cardboard, straws, stuff that you have at home or in the classroom. And then the Daily STEM by Chris Woods, that is an amazing book. It's a great resource on how to incorporate STEM into all of your learning experiences in the classroom. So I highly recommend that as well. Okay, so for the fun part, we're going to talk about bringing a light to an Arctic night and the electric circuit project. With this project, rather than just focusing only on the circuits and the connectivity, start over. Okay, so now for the electricity part and the circuits. So as a part of incorporating this project into design thinking and bringing in some authentic learning experiences, rather than teaching students how to create circuits and all of the terminology that goes with circuits and electron flow and simple and complex circuits, we put the whole project together in a design project based on real world applications and how you would use electricity and lighting in a real world environment. So in this case, we picked, because it's the season, an Arctic night. And we start the students by researching what is life like in the Arctic and what are some potential architectural adaptations to make life comfortable and functional in a place that's close to the North Pole. And then we start thinking about innovative lighting solutions and learn about different types of circuits in the context of why we would actually have different types of circuits in different scenarios. And then students will go on after their project to use some creative storytelling, and we have some options for students so that they can share their learning experiences from both the circuits and the electricity to everything that they learned about life in the Arctic. And it will finalize with student presentations if that's something that your group is interested in. So we start with adapting our home and what life is like in the Arctic, because how can they possibly design if they don't understand what it's like there? So in this part of the project, I have already created a link to 4 different learning resources that the students can have access to. But we also want the students to come up with their own research and their own resources and incorporate that into their project as well. So we started with a really fun one. If you didn't know this already, there actually is a Santa's house in the Arctic. Somebody built a real house to represent what Santa's house would look like. And it happened to be on realtor.com with a whole description. So I just shared a link to an article about Santa's house. But from a more realistic perspective, we also share some content about some unique and beautiful homes that are in existence in the Arctic Circle from an architectural perspective. And then there's a resource on how global warming is affecting these Arctic communities and how designers and architects and engineers can come up with some adaptations for living environments and structures that are built in a changing climate environment. And then lastly, I have a link to a description, a story about the most northern town on Earth that students can learn a little bit more about what it's like culturally up there. And then again, students should take at least 2 or 3 other resources based on this reading and areas that might interest them. Or maybe you have other learning objectives that you want to incorporate into it and have them research, like life science. Maybe you want to research the animals in the Arctic. Lots of opportunity for kind of spreading out and being a little bit more creative with the project. And then we're going to move on to circuits. So each one of the different types of circuits comes with a challenge that you would use that type of circuit for. In the lesson plan, I'm not going to go over here now, but in the lesson plan is all of the description of what is electricity, what is renewable energy. We go through the different types of circuits and the currents and voltage and all of that. So I'm not going to go over all of that with you in this presentation because it's all in the worksheet. You can read it with the students or have them read it. But I just want to go over how this circuit project can be applied to real life scenarios. So here is a simple circuit. This circuit, as you can tell, does not have a switch. So if you want, you can go ahead and try making this on a house. So you can start with building a simple house. Your pieces, should look something like this. Of course, your students are going to want to decorate them, but here's a very simple basic house. And here I already have an example of a simple circuit. Ignore the fact that this is separate. I can pull this out because I don't like to leave it on all the time, but your students can create this so that the light is on all the time unless you pull the battery off or the light off. And in our story and our description, the idea is that because the North Pole is dark 24 hours a day, in the winter time, the front door really should have a light that's on all the time. There's really no reason for a switch because it's dark all the time and people will get hurt if the light's not on all the time. So that would be an example of learning how a simple circuit works, but also incorporating that into a real world environment where you might want a simple circuit without a switch. So you can stop the video if you want and take some time to build your own simple circuit. You can use the lesson plan as a guide, but you know where the positive and the negative. In case you don't know, LED lighting, there is a positive and a negative. The positive is the longer arm, but you can read about that and you can practice making a simple circuit and putting it on your house. To make the light go on in our house, you'll notice that over here, I have all of the copper tape and the battery on the outside. This light over here is what you do is you poke a pencil in the cardboard and then you thread the light through, you split the leads, and then you create the circuit on the inside so that like in a real house, like the ceiling light or the lights on the walls, you don't see all of the electronics that's hidden behind the wall. So in our project with a cardboard house, you can see how it looks much more realistic than like something like a snap circuit where it doesn't have any application to any kind of house or anything that you would actually use it for. So when you're done making this simple circuit, you can play around with switches. So to create a switch, you're going to use an open circuit. So there's going to be a disruption somewhere in the circuit. So a good representation of that would be like this over here where it's interrupted. So obviously the circuit is I mean, I did it with the battery, but the circuit is not closed in that case. And then you're gonna make a little conductive switch. So in the image and on my example over here in the front of the house, the switch is made out of a little copper, hopefully this will work. There we go. A little copper brad. So I poked it in and I split it on the inside, and then I kind of turned each edge of the middle brad so that it definitely hits the copper. And with that, you can create a switch that goes on and off. And in our scenario, in the lesson plan, the explanation for having a switch, which is pretty obvious, is you might not want the light on at all times. So that could be a light inside their house. The description that I gave was that it would light the side yard so that only when kids are playing, not that anybody plays outside in the North Pole, but in the middle of the winter, maybe they do, but they can use a switch and put the light on only when they need it, therefore saving energy at times when they don't need it. Much like that. So I'll let you take some time. You can pause the video. You can try to make a switch, play around with it a little bit. And then when you're ready, we'll move on to the next project. Oh, no, I'm sorry. I take that back. We're not moving on. I'm going to tell you about other things that you can use for a switch other than a metal brad. So you can use a real switch, like the third one over on the right, on the top row. I can show you an example of how that would work. So this is actually something that my son made in high school. It is a pencil lathe in case you wanted to create some interesting carvings for your pencil. This will allow you to do that. Yes, it comes with a switchblade, which we don't need to worry about. But what I did want to show you is he rigged up this motor with one of those switches. So you can see this switch is part of the entire circuit, and it allows you to turn on and off, in this case, a lathe, but in your case, it's going to be a light. So that is one other material that you can use: paper clips, aluminum foil. Pretty much everybody has that at home. So you can use that if you need to for conductive tape. Electrical cords, alligator clips are another opportunity. And also pipe cleaners work really well. They're a little bit hard to make into a switch, but I'm going to show you another application that you can use with pipe cleaners in this project. So next, after you're done making a switch, here is a lower tech version of a smart home. So maybe you don't want to switch the light on and off every single time, but you just want your light to be activated when somebody's actually approaching the door and might actually come inside and need the light. So in this case, it's not actually, you don't really need what's it called, MakerBit or Arduino or any special kind of coding. You could do a low-tech version of it. So what I did, the little pussycat in the picture, is he has copper tape on his rear end. I put some copper tape on my little guy over here, and you can see, oh wait, first I have to turn it off with a switch. You can see how when this little guy comes up to, hopefully, there we go. When he comes up to the front door, the light goes on. And I can show you in this video how that works with a cat. Kids love this part. It's really fun. It's so cute. And they get really excited. And they can be creative because they can make anything that has copper on the bottom can become a conductor and close the circuit. So kids will have a great time with this project. And then next is more complex lighting. So once the kids make a simple circuit with switches or in a smart home version of a simple circuit, we can talk about if they need more light, and maybe they need more than one light and you don't want to have to use another battery for every single light and create a whole nother circuit. Another option is to use is to make a parallel circuit. So in the parallel circuit, just in case you don't know, you are using the same amount of voltage. It's just taking two pathways at the same time. So the lights do have to both go from negative to positive. So that can be a little tricky part for the students. Sorry, a tricky part for the students to make sure that they're getting the negatives on the same side and the positives on the same side. So I'm going to show you an example over here. All of our circuits on this one are on the inside. Let's see. There we go. It's not working so well, but so I'm just closing it because I created a switch on the inside. But you can see how the students can make something that requires a little bit more light in certain areas. And then lastly is this one's a little bit more challenging when you're trying to create a light in series. Depending on the LEDs and the batteries that you're using, because the series, each light is a resistor and it uses up some of the voltage essentially. So you're going to be needing more voltage than one typical battery, at least in our lights, which are 3 volts and the battery is 3 volts. So it's not going to light up well if you just do it with one battery. So this is an opportunity for students to go through the process and don't tell them that they need 2 batteries, but let them try to figure it out and come up with some solutions that might work. So you can play around again, trying to make a series yourself and seeing how you will need 2 batteries in series to complete the circuit and make both lights go on. So once you're done going over all the mechanics of learning circuits, the project is really just getting started here. Now it's time for students to use what they learned and put it in a nice creative storytelling piece. So I gave 2 options over here. If you have other ideas on how you want your students to create a presentation, by all means, be creative over here. But what I came up with, inspired by the Realtor article that I wrote, was to create an advertisement that allows the students a chance to explain why the home that they built is so great. And I spelled home wrong, sorry. It has 1 M. Why the home that they built is so perfectly adapted to life in the Arctic. So they can go over the different types of lights that they included, but they can also include some of the parts of the design of the home itself that they included. Did they put a fireplace? Did they, whatever they did research on and came up with as important ideas and concepts for putting into their home, this is an opportunity for them to share that. And again, this is where having each student do their own independent research comes in, because they'll all do different research and they'll all come up with different ideas on how to adapt their home, and they'll be able to share it with each other. Alternatively, you can, instead of creating an advertisement like a video or a magazine ad, your students can do some playwriting and create a story, pretending that they're the real estate agent, or maybe they're the potential homeowner visiting a home, asking questions and getting a tour of the home. So that could also be a really fun project for students. It allows them some creative writing, added research, and also the ability to create a story and present it to their peers. If that's not enough for you and your students can't put down their cardboard construction models and just want more, we have a lot of other lesson plans that could perfectly well fit into this project. So you can create a whole geometry and financial literacy component to this by going to our tiny house challenge and pulling out the area and the volume component and the cost of goods. So in our tiny house challenge, the students have to calculate the surface area, the volume, and the cost of all of the different building components that they used for their home. In a tiny house, I don't actually have the cost of the lights and the circuits component, but that's an opportunity for your students to add. Maybe they want to add how much per foot of copper tape do they need in their electrical circuit, and how much do the electrical lights cost, so that they could add that to the cost of their home. We also have a civics extension. So we have two tiny homes. We have a tiny home geometry, and then we have a tiny home cultural lesson plan. And the cultural lesson plan, it replicates a little bit what you're doing with Life in the Arctic and researching that. But here is a little bit deeper exploration of what architecture and homes are like in different communities around the world. So your students can dig a little bit deeper. Here's an example of a house in Thailand. So you can see there's bamboo material for the housing. It's on stilts because it's a waterfront property over a river. And you can see that their vegetables are on a boat because their supermarket is actually a floating market. As opposed to some of the projects from other parts around the world. Your students can create a formal presentation with creative writing, photography, and videography, and they can actually submit, or you can submit that to 3Dux, to our company, and we will actually promote it on our website and share that. That gives students a chance to really share their ideas and their creative projects with a much wider audience. Because kids from all over the world can go to the website and they can click on pages and they can see projects from all over the place. I also have, I know a lot of people here don't have 3Dux materials. I know I use the connectors a lot in our cardboard shapes, but you don't actually need them. I have a whole page on cardboard hacks that teach you how to do things with cardboard that allow students to make complex 3D structures without 3Dux. So it may be obvious, duct tape and glue and stuff like that, but I have, I think, about 8 or 9 different really fun and easy cardboard hacks that your students can do to make their structures a little bit cleaner, neater, and easier to construct. Here's a line of our products for the classroom. The Go Box, I don't have a picture of it here, but the Go Box Pro would be the one that has all of the electronic materials in it, as well as the mini kits that I sent people who wanted them. And I will share with you a sample of a presentation that incorporates not only a circuit project, but also some sustainable energy projects, civics, and it kind of incorporates a bunch of our lesson plans in one project that this class did. So I'll let you watch.
Looking at an aerial view of the site, Steel Point Harbor is a waterfront property with an adjacent uninhabited island. It is close to the Bridgeport Ferry, University of Bridgeport, a Bass Pro Shop, a Starbucks, and a Chipotle. It is also right near this awesome new education company called 3DuxDesign.
Before building our model, we created a site map with paper and Post-its to lay out the space and buildings. We divided it into focus teams, each responsible for a different aspect of the job.
Our teams included economic growth, education, recreation, cultural diversity and equity, and the environment.
This is our design. Starting with the island, we designed it as a zero-waste recreation area with a hotel, a farm-to-table restaurant, an ice cream shop, and a lighthouse museum. The entire island is designed to bring visitors and money to the community. It is 100% owned and run by the people of Bridgeport, supplying new jobs.
Our team opted for the sustainable feature side quest and learned how to run the island entirely on wind and solar power.
To celebrate cultural diversity, we designed a live performance and recreation center where locals could share their music, their culture, and have fun entertaining visitors. We believe that understanding and celebrating what makes us unique will foster a better sense of community and equity for the next generation.
No stage is complete without multicolored LED lighting and super modern seating, of course. The next part of our development is the before and after school center, perfect for working parents. It has a makerspace, a gymnasium, and a greenhouse where kids learn gardening and grow the food that supplies the Seaview Hotel with farm fresh produce.
The adjacent community forest includes a pond with a water feature, a swing set made from upcycled materials, and a meadow with a treehouse, home to wild animals and the cows that supply the island ice cream shop with fresh ingredients.
Next is the Adult Education Center. Many people in this community do not complete high school or college, so this is a perfect place for them to learn new skills. It has a library, an outdoor cafe, and an entrepreneurship innovation lab. There's a small business counseling service. Adults can broaden their skill set to join the workforce, get counseling on starting a business, and use the innovation lab to design and prototype their new ideas.
The adjacent startup alley is a line of pop-up shops that entrepreneurs can rent by the month to market test their startup ideas with real customers at low risk.
This beautiful seaside oasis is designed to give locals a place to enjoy, to learn, to socialize, to work, and most of all, to take pride in their city.
With a flourishing visitor center and influx of money to the city, this can be just the beginning. Thank you for listening, and we hope you like our proposal. If accepted, we would be happy to break ground today.
So I'm not going to go over all the different other side quests and projects that we have too much, but I'll just quickly flip through. We have culture and diversity with our landmark project. We have a getting down to business where students can actually open their own little mini business and they create a business model and learn about entrepreneurship. We have a bunch of sustainability based projects like our Busy Bee Challenge, where students design a pollinator pathway to support bees' life. An environmental cleanup project that one group did that's part of our Tiny Home Challenge. Fun with Friction is a great way to learn about slopes and different friction, different surfaces with friction, and learn how to do scientific design, scientific method with creating an experiment for how fast things slide down the slope with different surfaces on it. The recreation area of our community, we have a modern zoo challenge where kids learn simple machines as they design enclosures for each animal within the zoo. And that is it for my slideshow. So hope you enjoyed these projects. Of course, because it's a video, you can go back over and over again and see the different types of circuits and projects. For the lesson plan, you can visit me at www.3duxdesign.com and contact me, and I can send you the lesson plans if you don't have access to them. Or you can email me, marci@3duxdesign.com, and I can send you the link if you need it. So hope you enjoyed it, hope it was educational, and please make sure to send us your projects. We love to share students' work on our website. You don't have to have 3Dux products or connectors or anything for us to showcase great projects with hard work and a lot of time and effort being put into them. We love to share that with our community. So thank you for watching and hope you enjoyed it, and enjoy the rest of your day or nights.